Hi everyone, I hope you're all in good health and ready for today's lesson. Today we'll continue with propositional logic and we are going to talk about the rest of the chapter, hopefully. If you recall, this is the table we had in our previous video. We have a number of operators and their logical function. The operator tilde was used for the logical function of negation. Ampersand was used for the logical function of conjunction. We had tilde, which was, wedge, which was the logical function of disjunction. For condition, we use an arrow, and for equivalence, triple bar, although I didn't discuss it. Now, on the next slide, we'll see how the truth table functions with each of these logical functions. Okay, as you can see here on the slide, we have four, and then I'll show you a fifth one. Four other logical functions. The first one is negation. Remember that when we had a proposition, let's call it P, then we remember that it had either of two possibilities in terms of truth value. It could be either false or true. So as you can see here on the slide, I put here a T and F. Then we said that the negative form of that is negation, when there is this negation, the tilde negation operator, right? Then we will have the opposite values for, this proposition. For example, if I say I'm tired and it's true, then it is false to say that I'm not tired. Or it's not the case that I'm tired is false, right? Now, if it's not the case that I'm tired is true, then obviously I am tired is false. So there is this adverse relationship between these two. Next, we had conjunction, as you see it here, conjunction, right? The truth value for the truth table for the conjunction was that we had two proposition, obviously. Is that right? And then you remember we talked about this, the number of propositions. Well, here, of course, we have two propositions in all cases, but remember that the number of rows will depend on the number of propositions. And by the way, it doesn't really matter whether you call it a row or a line, because I was talking to a friend who apologized to me for using line. It doesn't really matter. So let's just say rows or lines. So we have two raised to the proposition number. It means if you have two propositions, so you will raise it to the second power. If you have three, you will raise it to the third power, and so on and so forth. So if I have, let's say, 7 propositions, so I'll raise it to the 7th power. So now that we have 2 propositions, so I'll raise it to the 2nd power, which makes it 4 rows or 4 lines. Now this is how we usually do it. We write P, and then depending on the number of lines, I'll write the first half as T, and then the second half as F. So I'll just write here T, T, F, and F. Is that right? And then here I alternate for the second proposition between truth and true and false. So the first one would be true, the second one would be false, then we have true, and then we have false for this proposition. But remember that this operator, conjunction, requires that both propositions be true for this to be true. In any other case, it is false. And this is what we will need to memorize, because we'll need this, okay? Especially when we are trying to check the invalidity of the arguments, we need this thing to remember. Feel free to refer back to these tables because it takes a while before you can memorize the truth value of different logical functions. The next one was disjunction. And with disjunction, remember we had again P and Q, so we have four lines or 4 rows. And then the only time it might be false is when both of them are false. And if you recall the case of the light bulb, we want to get what? The light bulb on, and this is the bulb, let's say, okay? So we had the 2 keys here, or the switches here. Now, if only both of them are off, this might not go on. If either of them is connected, then this light bulb will go on. So with that thing in mind, we can see that if we have 2 true, then my operator would be true, true, false, it will be true, false, true, it will be true. And the only time when it might be false is when this one is false and this one is also false, right? And finally, we had condition. We said that in case of condition, my condition operator is only false when the antecedent is true, but the consequent is false. This is what we discussed. So, like I said, feel free to refer back to these tables anytime you are doing one of these problems as we are working on, okay? So now let's move ahead and work on our truth table. Oh, I forgot something, and what that was biconditional. We don't have it in our books, but I think it's really good to know that the case of biconditionals, and it's easier to use this one rather than the one we have in our book, and that is the operator if and only if requires a truth value if both propositions have the same value. You see, both of them are F, so it is true. Both of them are true, so it is true. If one of them is true, the other one is false, as we have in this one, it will be false. Or if one is false, the other one is true, then again it is false. So it's good to remember this as well. You can just write them down somewhere, so you can refer back to them when you are doing your invalidity tests. Okay, so as you can see here, to understand about the validity or invalidity of an argument, we need a test. These are the methods that we can use. The truth table method, the short truth table method, and the method of deduction. We are not going to work on the method of deduction, and it's simply because we can check the validity, or better say invalidity of an argument through truth table method and short truth table method. So in that case, it might not be really necessary to learn the method of deduction. There are a lot of rules that we'll have to memorize. So I think for us, the truth table method as well as the short truth table method will suffice, okay? All right, so here, as you can see on this slide, I have put 2 things. I'm just going to focus on these 2. First, there is this truth table. I've put it here for reference, but once again, I'll just tell you that the operator condition is only false, as you can see here, when the antecedent is true, but the consequent is false, okay? Now, so what we do is for every proposition like this one, okay, what we need to do is draw the truth table, and then we should be looking for one and only one line, maybe, where we have a false conclusion but true premises. So this is an excerpt from your book. we present all of the possible circumstances for an argument by building a truth value for it, right? A truth table for it. Then we simply look to see if there are any circumstances in which the premises are all true and the conclusion false. If there are such circumstances, one row of truth table is all that is required. We don't have to prove that every line is wrong. No, if only one line or one row is false, then the argument is invalid. Okay, so let's just look at the truth value. By the way, when we have here, as you can see here, I have how many propositions do I have? One is P, one is Q. So we're just going to write P and Q, of course. Okay. Then one is not P, so I'll just write not P, as you can see here. And one is P and Q. So I just write on a different column. I write P, if P, then Q, right? And then finally, I write the conclusion. Okay. By the way, to make it easier for us, we can just draw two slashes here to say to separate what the premises and but this is what we're going to need for the next method. So just to familiarize you with this thing. So now we have our two propositions. Then we have one premise, we have another premise, and then we have my conclusion, which is not Q. Okay? Let me just draw one of the things here for you, and then we'll see the rest of them on the table that I showed. We said that because there are two propositions, definitely there are 4 rows. So, and then we had TT for the first column, and then false, false for the second part of the column, or half of the column. Now, we said that this is true, then the first proposition would be, because we would alternate between true and false, we would write true. Is that right? Now, when P is true, then not P is definitely false. Okay? And then here again, P is what? True. Q is true. Right? And this one, when both of them are true, it will be true, right? And Q is true, so not Q is false. So I'll just write here false for, and I can under this operator, because under this I'll have to write T. Just right under this I'll have to write what? T. But in our book, they don't write it. They just write truth value for the operator. So this is what my table will look like, as you can see here. Let's have a look here. The first 2 are true in our first proposition, the first column here, right, as you can see here. The second ones are F, and then we have alternating between T and F here. Okay, so let me just get rid of this bit, as we don't need it anymore. Okay, now let's just look at our not P values. So what you can do is look at P and the corresponding not P, see whether they're okay. So this T, then it should be false. Yes, it is false. This F, this should be true then. This is F, this should be true. Now let's just look at the functions for what? Truth function of condition. Now we said that P and Q, this arrow is only false when P, that is the antecedent, is true and the consequent is false. In any other cases, then it should be true. Is that right? That's right. Okay. And what about the last column, Q? So we should have what the opposite of column 2 is the reference column here. Now, look, if we have T here, we should have false here, right? And so on and so forth. So we can see TF, TF, FT, FT. So it means that's fine. Now, when I want to check the truth value, let me again rub off these things that I've drawn here, so you will not be feeling confused when I'm drawing some more lines. So we said that in case we wish to find out whether this argument is invalid or not, we need to, again, I'm reading this, present all of the possible circumstances for an argument by building a truth table. Well, I drew a truth table. Then we simply look to see if there are any circumstances in which the premises are true and the conclusion false. But I'll do it the other way around. Let's look at all the ones in which the conclusion is false. Okay, and here we have 2, right? And now I should check my operators to see if both of them are true and then this false. So let's start with the first one. This is my argument, right? I mean, if P and Q, then what? If P, then Q. Not P, therefore not Q. So this is F. This one is true. This one is F. So that's fine. I mean, there's no problem with this. This does not lead to inconsistency. And here I have false. If I can find truth value for both premises here, then I can claim that this argument is invalid. And look, here we have T and another T. So it means that this argument is not valid. So it is invalid. Why? Can you tell me why? Because we have the premises are true, but the conclusion is false. And this can't be the case. Now, so how many rows of inconsistency did I find? Only one row, this one. So that is enough for me to say that this argument is invalid. I think we'll look at some other examples and we'll understand this better. Okay, so here's another example from your book. Now what you can do is you can pause the video and read this sentence or argument. Okay, did you read? Let's read it together. Now, we are going to have large mass of Arctic air. Let's just call it A. So we have proposition A. And we always write all of them. I mean, all of the propositions as reference propositions, okay? We are going to have large mass of Arctic air flowing in the Midwest unless the jet stream moves south. So I'll just write J, okay? And then it says, unfortunately, there is no chance of the jet stream moving south. So it's negation, right? Say no chance of J moving out, right? Therefore, so you can bet there will be Arctic air flowing into the Midwest. Because this is the conclusion, I'm just going to write it here, A, okay? This is the conclusion. And here we had another one. So let me just now write them vertically. So we are going to have large masses of Arctic air. We can just do it like this, maybe here, right? And then I'll rub it off. So A, now remember what is the operator here? It is unless, and remember unless, we said that it's a kind of disjunction, right? So we can translate it as injunction. So that will be this or J, okay? Then it says, unfortunately, there is no chance of the jet stream moving south. So no jet stream moving south. Therefore, we are going to stick with this Arctic air, right? So that is A. Sorry. I don't know. So this is my argument, and I'm going to write it. A and J are my reference column, so I'm just going to write them down. I've written here not J, so all I need to write is put it here. So I just write A or J. Okay, so now I'll just drop this part off. Okay, and all right, so I can just start. So one column here, one column here. I'm just going to draw these so you will see how we can do this. Okay. So again, we have two propositions. How many rows? We will have 4 rows. Okay, so I'll just write it like this so we can, in a sense, do it more neatly, but I'm not sure that it is that neat. Okay, so what we need to worry about would be these 2 operations. First, I'll write them down. True, remember, again, half of them you write true, the other half you will just write false, right? False. I hope that you can see this. False. Okay. Here we would alternate between true and false. Okay. True and false. Okay. Now, obviously, negation would make an opposite. So if J is true, then not J is false. If it is false, then it is true. I'll just write F and T here as well because we know why they're F and T. Okay, so I'll plug in the values for A and J here as well, but I'm not now worried about it. Let me just write for what or what. When is or false? Remember, it's only false with disjunction. It's only false when both, excuse me, A and J are false. Is that right? So if you just plug in these 2 things here, right, this F and this F here, so you will get that one, what? False. Now I don't have to plug in this one and this one here and here, but what I will do is I'll write T for the rest of them, okay? I mean, you can just go ahead and write, but it's going to be very time consuming for me with this mouse of mine used to write things. Okay, now let's look at these 2 things. So I have, I have this one, I have this one. What about A? The same things for A. I'll have to write AT, AF, and what? AF. Okay. Now, remember what we are worried about is that we find one row where we have discrepancies. Okay, so let me just write this one for you too. This one is J is true. Is that right? J is true here, as you can see, and A is false, right? Now, here, I'll have to check these 2 false statements because our rule was, I mean, if you want one argument to be valid, it can't have true premises for all and then false premises. Is that right? So now let's look at this. This is true, right? The conjunction here, sorry, disjunction here. This is true, this is false. So that's fine. Now, this is true, this is false. So this is also false. Yeah. So unfortunately, I couldn't prove that this argument is invalid. So the argument is valid. So let me just write valid. Okay. So now I think we can move ahead and work on another example. Okay, so here's another example for you. this is a bit more complicated because we have more operators, as you can see. So please pause the video and try to figure out how many propositions we have here and what the operators are. Good. I hope you pause the video and try to see what the operators are. So what letters did you choose? For example, here for Scarlett, we can use S, okay? For Mrs. White, we can use W. So it says, if Scarlett is guilty of the crime, then Mrs. White must have left the back door unlocked. We have another operator here. So we have one operator if, and the other operator here and, okay? And the colonel must have retired before 10 o'clock. By the way, retired here means go to bed or sleep. Okay, so here, Colonel C. So we have S, W, and Colonel and two operators, okay? Now, what you need to do now is, as you're translating, trying to figure out which of these two is the main operator, okay? Now, so retired before 10 o'clock. However, either Mrs. White did not leave, so that is W, but it's not W, leave the back door unlocked, or the colonel did not retire before 10. So here we have not C. Therefore, S, not S, right? Because Scarlett is not guilty of crime. Therefore, not S. So you can just write it down on the next slide. I'll show you how we can draw the table. But before you we move ahead, please pause the video and draw the table as well, okay? Now, as you can see here, we have the truth table, right? We said S is Scarlett, W is the White, Colonel is C, not W, not C, not S. Okay, so what matters here is that we have the vertical translation here. Okay, so now we have two operators here in the first sentence. If Scarlett is guilty of the crime, this is S, right? If S, right? Then W and C. Then Mr. White must have left the back door unlocked. This one. And the colonel must have retired before 10 o'clock, right? So C. And the next one is, however, either Mrs. White did not, so not W, or then the colonel did not retire before 10. That is obviously not C. So therefore, and that is, this line shows therefore for us here, okay? Therefore, not S. That is, Scarlett is not guilty of the crime. Okay. So now we have three propositions here. Remember, we have to raise to the third power now to decide how many lines we need. Okay, so here we have 2 times 2 times 2, which makes it 8. Okay, now, so let's have a look. We have our references here, the 3 references here, okay? T. Well, let me just go down one. Remember that we write half of them as true, half of them as false. So 4 here are true, and then the next 4 are false. Then we will do it in pairs for the second proposition and alternate between true and false on the third column. Now, so I think we are ready. So not W would be the opposite truth value of this column, right? So if this is true, then not W is false, right? And so on. You will have to check these 2, okay? Check these 2. I'm not going to write the rest of them here for you. Okay. Now, And let's go ahead with not C. Again, opposite value for but C. This C is true, this is false. This is false, this is true, and so on and so on. Now, what about W and C? Okay, so let's write W and C and then write it in this column, column 6, because here we have the W and 6 here on the right. You can see that, right? Okay, so let's go to these two lines. Let me rub off this thing and start all over again. Okay, so for W and C, here in the first one we have true, true, true. So the value for this would be true. Remember, for a conjunction to be true, both of these should be true. Now look at this. It's true, but this one is false. So it should be false. Now look for columns where you have T for both of them. And then here we have T for both of them. So W and C should be true. So let's go and check. Yes, it is true. What about the rest of them? TF, it should be false. FT, it should be false. FF, it should be false. So here we have two true values. Is that right? Okay, now let's go to our argument, which is if S, then W and C. Okay, so what is the main operator here? I hope that they had drawn this under this. This is for this one, okay? So, yeah. Now let's check S. And where is S? Here it is S. So let's just write S. For the first one, I'll write S here. And the value of this one, what is this? Now, do I really need to know this, W and C? I mean, the value, I mean, do I have to look at the column? Not really, because when was conditional, sorry, I made a mistake. No, that's fine. Let's just do. Here we have T. So I just write T here. Remember, for conditionals, if both are true, then it is true, right? But now look at these here, which say F, F, and F. When do we have F for conditionals? Only if the antecedent is the antecedent. If we just have P and Q, let me just write it here, right? If the antecedent is true and the consequent is false, then condition would be false. So in these three cases, what I am sure is that W and C must be false and S must be true. So let's just check them. Now W and C, oh, it's not W. Okay, should be false, false, false. But let's check the S value. Check the S value, S. For the second, third, it's true. So you see, that's fine. Well, of course, this was only a check, but remember that you need to look at S, you look at W and C value, and then you write this thing here, okay? Then for the rest of them, they are true. Let's see, if F is, sorry, if the antecedent is false, then my condition operator would always be true, no matter what the consequent is. And here, because all of them are false, I know these four are false, then definitely this one would be, these four would be true, right? Okay, now let's look at the next column. Okay, that is not W or not C. Now, when we say that the disjunction is false, a disjunction is false if only both propositions are false. Is that right? I mean, both of these should be false, so I can say that this is false. I mean, this operator is false. Okay, now let's just check it. Not W is false. Not S, where is not S? Not S. Here, not S. But you don't have to look at not S, you can look at S and then the negate it to get this. But anyways, not S is F, so it's going to be F. So I see that both of them are false. True, it doesn't really matter if both of them are true or one of them is true, then that suffices. So, but let's just check them 2, 3 more. So it is true. Let's just check this one, the value for this one, not W, it is false. Then for this to be true, what should this be? Definitely true. Is that right? So let's look at number 2. Mine, not C. Not C is false. Sorry, it's true here. Right, the second one is true. So what does this mean? This means that this is okay. Let's just check another one here. F, when is it F? Definitely both of them should be false for this to be false. So let's just do it. Let's look at not W here is false. You see that? And not C is also false. So that's okay. Now let's look at the next. Well, I think you hopefully got the idea what we are doing here. Let me just rub off these things because I think they are getting too messy and impossible to see. Okay. Now, based on these two, I need to what? Now I need to check these things. So first, what is the? It's not S. What I need to write here as the values would be opposite of S. So remember, the first 4 were true. The last 4 were false. Then I can reverse these things. So the first 4 are false. The next are true. Okay, so what I need to worry about is when my conclusion is false, but I have all true premises, or all my premises are true. So how many premises do I have here? 1, 2. So I'll check the value for this and the value for this. I mean the functions that we have here. This one, let's just say, and this one, okay, and this refers to that. If both of them are true and my conclusion is false, then my argument is invalid. But let's see, false, true, no, that's okay. False, true, that's okay. False, true, that's okay. So unfortunately, I couldn't prove that this argument is invalid. So it means that the argument is valid. Yes. Okay, so let's focus on the short truth table method. We have talked about truth table method, and now we are going to focus on short truth table method. Let's see why we have to use short truth table method. Remember I told you that in order to write the number of lines, we'll have to raise 2 to the nth power of propositions, right? I mean, because we said the number of lines or rows is a function of the number of propositions. So in this case, what we could write is 2 to the power of n. Is that right? So if we had 2 propositions, that would be 2 raised to the 2nd power. So that would be 4. Is that right? So let me just write 2 to the power of 2, right? That would be 4. But then this would become 8 if we had 3 propositions, 16 if we had 4 propositions, 32 if we had 5. And I just, you see that the number of lines rises exponentially, and it might be a bit unwieldy for us to handle. I mean, it's impossible for us. Like Moore says, our life is not that long to be spending so much time on writing all those lines. So what we can do is to use the short truth table method, and it makes it very easy for us to handle, especially if there are many propositions. I don't know why I can't get rid of this. Okay. Well, here we have one example for you. Imagine this is our proposition. Okay, so the proposition says if P then Q, Q therefore P. Now I'm going to use a different way of writing this as opposed to what we have in your book. It might be easier for you to handle. Okay. What I use is use a slash to separate premises, and then double slash to separate the conclusion. So as you can see here, I say if P then Q, and then Q, and therefore P. Just like what we have here. Now, I have also placed the conditional truth table here for you. Remember that a conditional operator is only false if the antecedent is true and the consequent is false. And I keep repeating this because this is all we need to remember to be able to actually find the truth value or the invalidity of an argument here. So let's just focus on P. Remember we said that one argument is false if and only if the premises are true and the conclusion is false. So it means it can't be the case that in a deduction the premises are true and the conclusion false. So if this is the case, now I'm just going to use reverse engineering. I mean, this is what we do in the short table truth method. So we say that it's impossible for P to be false given that this premise is true and this one is true too. Okay? So if I can prove that this is T and this is T and this is F, then the argument is invalid, right? So what I do is now I consider P as F because this is what I want to prove, right? So I want to prove that this argument is invalid. Remember, in short truth table method, we try to say that the argument is invalid. We try to prove it. So the game is prove it wrong, okay? So let's just see what the value for for P is here. Because it's a conclusion, I choose F. Now, wherever I find P, I'm going to insert F, okay? So here, here. So I just press it. I plug in F here. And here for Q, what I'm going to do is I'm going to plug in T. Okay, yes, here, T. Now, let's forget about this part for a bit and then come back to it and write it down. Look at this table now. If my antecedent is false and my consequent is what? True, as we see here. True. What would this operator of condition have as value? It will have T. So it is correct, right? So it's true. Now we are having true, we are having true, and we are having false. Done. Great. This is invalid, right? And this is invalid. Why? Because I proved it, that I can have two true premises and a false premise without breaking any other rules, right? Okay. Let's look at another example. Let's look at this example. You can pause the video and you can do this yourself to see whether this is valid or invalid, and then you can watch the video to check your answer. Okay, I hope that you have done it and you're now waiting for me to go ahead with this. So it's almost the same thing, except that here I have to prove that Q is false. So we know that for this to be false and this argument to be invalid, I should have the premise, true premises. So I'll have to write T here, right? And here for this operator, I'll have to have T2. Now, let's see whether it's possible. So let's plug in, because here we have Q as false. Anywhere in the premises where I see Q, I should put F, right? So here, yes, F. And here, yeah, well, there was one Q and I did it. And here P is true, so I'll have to plug in T here. And now a question, is this possible? I mean, can I have a true antecedent in a condition? Can I have a true antecedent and a false consequent? Yes, I can. But then the value of this condition won't be true. Is that right? It has to be false. So this is not possible. When it's not possible, it means I will have to write F here rather than T. So the argument is valid if it is false, true, false. It's only invalid if both premises are true and the conclusion is false. But I couldn't do it here, so I was unsuccessful. So this argument is a valid argument. Valid. Okay. Now I hope you understood that. Let's look at them. Okay, now here is what we have. As you can see, this is more complicated than the other ones. How many premises do you see here? Yeah, one is T, one is W, one is R, one is S. Now these are things T is we have here, Q. Oh God, yeah. So how many? We have 5, and this one is R. We have it here, and not S is, let's say, the same thing. So how many rows do I need to this? That would be 2 raised to the 5th power. So that would be 2 times 2 times 2 times 2 times 2. That is 2, 4, 8, 16, 32 lines. You see, now it's getting more meaningful for us to use short truth table rather than having 32 lines. What I can do is write the way we learned, okay, and then try to figure out the truth value of this argument. So please pause the video and first write it rather than vertically, write it horizontally, okay? Remember that we use slashes to separate the premises. So let's see whether you have written it like this. You can pause the video now again and check, see whether you've written it the same way. So now let's see what we do. Here, remember that we need to prove that this thing is the conclusion and it is false, okay? That this thing as a premise should be true. This thing in the condition should be true. And here we have 3 operators. Which one is the top level operator? Here we have and. I should also prove that this is true. So if I can prove that these 3 are true and yet the conclusion is false, then I can prove the invalidity of my argument. Is that right? Yes, we just said that if I can prove that one line is what I can find true premises and one false conclusion, then I can say that this argument is invalid. So now let's go ahead and see here we have negation. The negation is the whole thing. So this is false, right? So if the negation is false, then it means S is true, right? So now this is not a compound premise, so it means it is true, right? Okay. So now let's look here. Here, what do I have? I have an S its value is known, and an R, its value is known. Let's just plug in anywhere I see R and S, okay? And because I have the truth value of these two letters. So R here, this one should be true then, right? Here R again, so this one should be true. Okay, now anywhere else? No, there's nowhere else. Now S, let's find S. Here I have S, and it should be what? It should be false. Sorry, true, because not S is true, right? Okay. So now that I have these things, I need three more things. I mean, I need to decide what these three more things are. Now, let's go ahead and think of this one. Well, by the way, it doesn't really matter which one you pick. You can just do whatever. But let's just pick this one, which is easier. Like this is what operator? It is conjunction. Do you remember the truth value for the conjunction? If you don't, please pause the video and go back to that table. I wish I'd put the table here so we wouldn't have to go away, but you can just stop the video and look. Remember that in this operator conjunction, it can only be true if both propositions are true. Is that right? If both propositions are true. So if any of them is false or both of them are false, then it's not possible. So for this to happen, then remember that both of these two, let me just see whether I can use a highlighter. Both of these should be what? Should be true for this operator, to be true. Okay, so if this is the case, again, I have another operator here, conjunction operator, and it can only be true if I can write T for both. So I can just write T for both, for this one to become T, okay, to become T. So I write T for both of them. Now, I see that T and T can give me a T. So let me just write it here, okay? So if this whole thing is true, right? Let's plug in now T, if we have it anywhere else, T, I mean the value for T, yes, we have a T here, so let's just write T for this. And then decide what the operators are here. So for this one, we calculated that it can be possible to achieve a T. Now in condition operation here, I mean, if we had the antecedent as true and the consequent as true, then what would be the operator? It would be true. Now we have true here, right? True here, and then when these two are true, this one will be true. Fine. Okay, so this one is okay, no contradiction. Here, again, the condition, when the antecedent is true and the consequent is true, then this one would also be true. So there is no contradiction here, so true. And this one from the beginning was fine. So now you can see that we have three true premises, but unfortunately we have a false conclusion. So it means, yes, I did it, and I proved this to be invalid, right? Because I couldn't find any contradictions here. Okay, so with the next example, we'll see something different. Oh, why is it like this? Okay, fine. All right, so this is, I think, our last example, if I'm not mistaken. Maybe not, maybe there's one more left. Okay. The reason why I'm giving you all these examples is for you to get used to the way we are doing it. So let's just write this in a line format, okay? And see how we can do this. I'm just going to ask you to pause the video, do this, solve it, and then watch me do the same thing, okay? So I'm just going to pause it myself. Okay, so remember, we should be able to force all premises to be true without any contradiction, Okay, if we can do that, then we can say that this is invalid. So this is our game. Again, we are playing this game. Let's go ahead with this first one. Here, for the conclusion, how many operators do we have? Two. This one and this one. Which one is the top level operator? This one, right? So this should be false. How can I make this false? Only if this is true and this is false. So let me just write for D, false, okay? And for this, true. So this would be true. It means C will be false, right? Okay, so now I'll have to prove that these three operators, I'll have to force that these three premises, should be what? Should be true. So here the main one is here, this one. This should be true. Here it is this one. It should be true. And here, because it's not a compound, this should be true. So let's just write T here. So if I can prove that these three, if I can force them to be true, then this one is false, then I can claim that this argument is invalid. So let's go ahead and plug in A, C, and D wherever I see them. D, I have it here, and it is false. I should write F here, okay? C, I have it here, so it should be false, okay? And A, I have it here, it should be true, so it is true, okay? Now, so let's look at this one. Okay, so what do we do with this? If I want this to be true and this to be false, then definitely this should also be false. Remember that in if you look at the truth table of condition, if this is true and this is false, this would be false. So the only way I can get this to be true is to choose F for this. And I don't want to, I don't want to, go against my own game. So I'll just pick F for this. If I pick F for this, I'll have to pick F for this too, right? It's have no choice. So now there's a problem here. The problem is when I had this operator, there's this junction, the only way it could be false would be when both of these two, B and C, are false. And unfortunately, both of them are false. So when this is false, yep, this operator then can't be true. Why? Because if the antecedent is true and the consequent is false, then I would say that this is, unfortunately, what? Not the case. I can't force this. So unfortunately, we were not able to force all the premises to be true. This proved to be false. Therefore, this argument is what? Valid, because I couldn't force or dictate my wishes here. Now, let's look at the last example. Okay, this is our last example. What if our last example is like this? Not A, if not A, then B. If B, then A. If A, then not B. Therefore, A and not B. So pause the video and write the line for this argument, okay? So please pause. All right, I hope that you have written it like this, right? Now, let's do this together. Again, we are trying to see whether this argument is valid or not. And remember that if any line can lead to contradiction, then we say that the argument is invalid. And this is what we hope, because that's how we play this game. So now what do I have to do here? I'll have to prove that this one, because this is the main operator, that this one is false, right? but that the rest of the premises are true. So it means this one is the main operator, this one should be true, this one should be true, and this one should also be true. Okay? Now, let's look at this one. The reason why I chose this actually exercise for you is that, unfortunately, you see, because it's a disjunction, there are 3 cases where the disjunction will give us a false result. I mean, a truth value of false. Remember, the only time that a conjunction could be true was if both of them are what? True. But now I'm trying to prove that it's false. So I need more than one line to check the invalidity of this argument. So now if this is the case, so I want an F here, but then it could be that A is true and not B is false. Okay? So if this is the case, then this would be false. I mean, my conjunction operator, right? Then another case of false would be when this is false, but not B is true. Okay? Then again, my conjunction would be false. Then the last one would be when both of them are false. So if this is false and not B is false, okay, then this would also be false. Okay. Now, so if this is the case, let's just move backward and I'll just draw a line. Well, strangely enough, the line is now good. It's not very terrible. Now, so if, let's first plug in A. Anywhere we have A. A is true here, therefore here it is true. Okay, here it is true. Just draw this slash. And here, not A should be false then, okay? I mean, not A should be false. This is for this one, of course, for the tilde. All right. Now, what about B? Not B is false. Therefore, B is true, okay? B is true. So let's just go, not B is false. So I just write F here, okay? B is true, so I write true here. And B is true, I write true here. So now when I have a false antecedent and a true consequent, what would be the truth value of my condition? True. So it's okay here. I could force true here. What about here? If both the antecedent and the consequent are true, then I could just say true. Unfortunately, it doesn't work here. I mean, I can't force if I say A is true, and I mean the antecedent is true, and the consequent is false. Then unfortunately, this becomes false. So here I have a contradiction. I mean, I can't force the value, the truth value for the for the propositions to get a true one. So unfortunately, this shows that it's valid. So far, it's valid. Is that right? But I'm hopeful that it can be invalid maybe with the other lines. Remember that if any of the lines or the rows can prove that we have true premises, all premises are true, but the conclusion is false, then that would mean invalidity for our argument. So let's go to this one. So again, this time it's F. A is F. So let's plug in A is false. Now here A is false. Okay. Here not A is then true. Okay. Now, what about B? Not B is true, therefore B is false, right? So not B is true, right? B is false, am I right? B is false. And here, B is false. Okay. So now let's look at the operator for the first proposition here, condition. The antecedent is true and the consequent is false. Oh, it should be false.
So here I have contradiction. Now, do I have to go ahead with the rest? I'll do that. It's not necessary because I found something that I could not force the truth value on. So, but I'll do it. If both the antecedent and the consequent are false, then the condition truth value would be true. And if the antecedent is false and the consequent is true, then it is true. So these two are okay, but this one, the first one, I couldn't get it right. So this is also valid, so ditto. Let's look at the third one now. Let's imagine that this one is false, A, and plug in A. So we have A again is false, and not A is true, okay? And B, not B is false, therefore this one will be true. B will be true. So let me just write not B is false, okay? So if the antecedent is false and this one is false, the consequent, then this would be true. So this is fine, it's okay here. What about this one? B, so I should plug in B here. B is true, so if it is true, so I'll just put it here, and let me put B here too. Yeah, well, I can just do this. So again, we can see that here the antecedent is true and the consequent is false. So unfortunately, this is false. It can't be true, right? So here I have contradiction. So it means this is valid, and I couldn't prove the invalidity of this argument. And obviously, if the antecedent is true and the consequent is true, this operator is also true. Yep, that's it. I hope you understood how you will have to check the validity, or better say, invalidity of such argument. The method of deduction is the third way of checking the validity of an argument. And actually, this is the way to check the validity. The other two means we used were, as I told you, we were after checking the invalidity. I mean, we wanted to prove that an argument is invalid, but here we try to prove the validity of an argument. But since those two ways, I think, are enough for you for this course, that's enough to know how we can just check the validity. So we are going to skip this part, and you don't need to worry about it. Thank you very much for watching. Take care of yourselves and your families. Bye.